Hey everyone, today we are going to learn how to secure a Laravel API using JWT, and we will use Timon third-party JWT Auth library. But first, what is JWT? JSON Web Token is an open standard, RFC 7519, and it represents a compact and self-contained method for securely transmitting information between parties as a JSON object. It authenticates the incoming request and provides an additional security layer to REST API, which is best for security purposes. First, let's add require our package, and I will link the website in the description below. And then after it is installed, let's go to our config app.php and add our providers, and then we need to publish it in our application. After that, we will generate our JWT secret, which is unique for every application. And now we will have to update our user model so it implements JWT. Then we need to go to our auth.php to configure our guards, so we will add the API guard and make its driver as JWT. So now when a user authenticate from an API, it will use JWT, and the provider is users. That means it will check the user model for the authentication. Now let's make our auth controller. So first of all, in the login, we are validating the fields that we want, and then throw an error if it fails or attempt to authenticate the user if it succeeds. If the user credentials are right, we will make a new JWT token and authenticate the user. If not, we will return an error message to the user. Our register function is doing the same things with the validation. And if it's true, we will create a new user and hash the password and store it in the database. The logout destroys the token, making it invalid and make the user log out from the application. The refresh create a new token for the authenticated user. User profile returns the user's info and the create new token returns the info of the token and the info of the authenticated user. Then we need to register our functions in the routes using middleware of API and a prefix of auth. And now let's test our application and see how it works using Postman. But first, we need to make a new database. So let's set the name of our database, and then we go to our PHP, my admin, and create a new database. And then we run the migration command, which is php artisan migrate. And now we have our database ready for testing. Let's run our application using php artisan serve and go to Postman to test it. First, we will put our local host URL, and then our middleware and prefix, and then our fields, so we can create a new user since our database is empty. Okay, let's remove the password confirmation from the password validation. We don't need it. And then we run it again, and user is successfully registered. Now let's try to log in, and for login, we need email and password, and now our access token is generated and we are logged in successfully. Now we take our access token and put inside the authorization in Postman, and we set the type to bearer. And now we are logged in our application using this token.
In summary, Vite is a next-generation build tool that prioritizes speed, efficiency, and developer experience. By leveraging modern browser capabilities and embracing the principles of incremental development, Vite empowers developers to build better web applications faster than ever before. Now let's make our React application using Vite. We will use this command and let's follow the instructions. Now after we have created our React application, let's run it using npm run dev. And we will get this page with a small counter, and that's great. Now let's start our real work. Let's first go to our React application, which is located inside our Laravel application, and let's delete some things that are installed with it. Next we need to install React Router DOM. What is the React Router DOM? React Router DOM is a popular library for managing navigation and routing in React applications. It allows developers to create dynamic, single-page applications with multiple views, all while maintaining a clean and intuitive user experience. Now after that, let's make a new folder called View, and inside of it we will put our views files. First we will make the login view and the register view. Then let's make a file called router. What will this file do? The primary purpose of a router file is to serve as a centralized location for configuring routing within a React application. This file typically imports the necessary routing components and defines the routing configuration for the entire application. It defines the routes, handles navigation, and ensures that the correct components are rendered based on the URL path. By centralizing routing configuration, it helps maintain a structured and organized approach to navigation within the application. The browser router component acts as the root of your application's routing functionality, while root components define the mapping between URLs and React components. With React Router DOM, you can easily define routes for different views and handle navigation between them seamlessly. Now inside of it we will make two new paths for the login and for the register. We need two elements. First the path, which is the URL that we need to access to get to that element, and the second is the element. So that means when we go to the URL login, we will go to the login view and render that page. And we will do the same thing for the register view. Next we need to go to our main file and add the router. But what is happening here, and what is the React strict mode? It is a built-in React component that helps identify potential problems in your code and highlights them in development mode. It doesn't render any visible UI itself but activates additional checks and warnings for child components and their descendants. It's primarily used during development to catch and highlight potential issues such as deprecated lifecycle methods, unsafe component lifecycles, and legacy APIs. It helps you write cleaner and more reliable code by providing helpful warnings. By wrapping your application components with Router Provider, you're making the routing functionality available throughout the application. This allows you to use routing features such as navigating between different views or rendering components based on URL paths. Overall, it initializes the routing functionality using Router Provider, possibly from a router library like React Router, and ensures stricter development checks and warnings using React Strict Mode. This helps in building robust and reliable React applications with enhanced debugging capabilities during development. Next, let's make a small login and register views just so we can make sure everything is working just fine. We will just make the login function and make it return a div with the word login, and we will next do the same thing for the register view. Now let's run our application using npm run dev and go to the login page. And we will get an empty page, so there is a problem with our routing. The element shouldn't start with a small letter and also the import, so let's fix them and try again. And we will get our register page and our login page just like we want, so now we made sure our routing is working just like we want it to. Now let's make a new folder and call it components. Inside of it we will make two files, one default layout, and the second called guest layout. Let's make a small return div inside of them, so let's copy the code from the register and make it for them. And I will explain what we will do with them while I write the code. In many React applications, especially those using React Router for navigation, it's common to have a default layout component. This component serves as a template or wrapper for other components, providing a consistent layout and structure across different pages of the application. Why we use a default layout component? By using a default layout component, we ensure that all pages of our application have a consistent look and feel. This improves user experience and makes navigation more intuitive. Instead of duplicating layout code in every page component, we centralize it in the default layout. This promotes code reusability and makes maintenance easier. The default layout component can be customized to accommodate different design requirements or user interface elements. This flexibility allows us to adapt the layout as needed without modifying individual page components. With a default layout component, navigation-related elements such as headers, footers, or sidebars can be managed centrally. This simplifies navigation logic and reduces the complexity of individual page components. In conclusion, the default layout component in React Router plays a crucial role in providing consistency, code reusability, flexibility, and simplified navigation in our applications. By centralizing layout logic and structure, it helps create a cohesive user experience and streamline development efforts. Now let's make a users file so we can make the users view later. Now let's go to our router and add all the new routes. In React Router, the term children refers to nested routes or components within a parent route. When defining routes using React Router, you can specify routes as children of other routes, creating a hierarchical structure for navigation within your application. When a route has children defined, it means that those routes are nested under the parent route. This nesting can be visualized as a tree-like structure, where each parent route can have multiple child routes associated with it. So what are the benefits of using children? Children routes allow you to modularize your application's routing configuration. Instead of defining all routes at the top level, you can organize them hierarchically based on their relationships. By nesting routes as children, you can create complex navigation structures that scale well with your application's growth. This makes it easier to manage routing in large applications with many different views and components. Children routes can also be used to implement route guards or middleware logic. You can define common behavior or checks at the parent route level, which will apply to all child routes nested under it. In summary, the concept of children routes in React Router allows you to create hierarchical navigation structures and modularize your application's routing configuration. By nesting routes as children, you can create scalable and maintainable routing solutions that enhance the user experience and development process. Now we will learn something that is called outlet we need to use inside our guest and default layouts. What is this outlet? A placeholder component used in React Router for rendering child components or routes. It serves as the insertion point for child components defined within the parent route's configuration. When a parent route component, such as the default layout component in this case, is rendered, it may contain nested child components or routes. The outlet component within the parent route's JSX acts as a placeholder where these child components or routes will be rendered. React Router dynamically renders the appropriate child components or routes defined under the parent route and inserts them into the outlet component's location within the parent's DOM structure. It allows for dynamic rendering of child components or routes within the parent route's layout. This enables the creation of flexible and scalable routing solutions. And by using outlet, the layout component remains agnostic of the specific child components or routes it renders. This promotes a clear separation of concerns between layout and content. In summary, outlet in the default layout component serves as a placeholder for rendering child components or routes defined within the parent route's configuration. It allows for dynamic rendering of content while promoting separation of concerns and facilitating the creation of flexible routing solutions in React Router. Now let's run our application to test everything, and we got an error in our default layout file. We forgot to import the outlet from the React Router DOM. So now let's try again, and everything is working fine, and if we go to the login page we will get guest login, and that's what we want. Now let's try and go to the users page, and we will get default users. So now the default layout and guest layout are working just fine. Now let's make our context folder so we can start our real work inside of it. Inside the context folder we will make a new file and call it context provider. At its core, state context is created using React's createContext function. This is the first step in establishing a global state that can be accessed across different components without the need to prop drill. Let's break down the initial structure. Here, createContext is called with an initial object. This object contains two properties, user and token, both initialized to null. But why these two? The answer lies in their universal importance. The user property is intended to store user information, typically set after a successful login operation. It could include the user's name, email, or any other identifying data crucial for user experience customization. The token, on the other hand, is all about security. It's the authentication token received upon logging in, acting as a key to access protected routes and resources. By storing it in our context, we ensure that it's readily available for securing API requests and managing session states. Once state context is established, it becomes a beacon of data for components deep in our application's hierarchy. Components can subscribe to this context and react dynamically to changes in user information or authentication status, fostering a cohesive and responsive user experience. The context provider serves as the cornerstone of our state management strategy. It wraps our application's component tree, allowing every child component to access the state without prop drilling. Notice how it accepts children, a prop representing the child components that context provider will wrap. This design enables any level of the component tree to access the shared state. Within context provider, we manage two crucial pieces of state, user and token. User is initialized as an empty object, ready to store user details, and token fetches the authentication token from local storage, ensuring persistent login sessions. We also provide a setter function for the token to not only update its state but to interact with the browser's local storage, adding or removing the token as needed. The setToken function plays a dual role. When a token is present, it's stored in both the state and local storage. This ensures that the user remains authenticated across sessions. Conversely, when logging out, this token is removed from both the state and local storage, securing the user's session. The magic happens when we use state context provider to pass down user, token, set user, and set token to the entire component tree. This pattern ensures that any component, regardless of its depth, can access and manipulate the user state and authentication status effortlessly. To access our context easily, we export useStateContext, a custom hook that taps into state context using useContext. This abstraction simplifies the consumption of our context, making it more intuitive for developers to integrate state management into their components. And we forgot to add set user and set token in the state context, so let's add them. Next, let's go to our default layout. The default layout component plays a pivotal role in our application structure. It acts as a guardian, deciding which parts of our application are accessible to users based on their authentication status. First, default layout taps into our global state using the useStateContext hook. This hook grants us access to the user's authentication token and other user details, enabling us to make informed decisions about what the user can access. By destructuring token from our context, we can easily check if the user is authenticated or not. The core functionality of default layout revolves around this simple yet effective check. If there's no token, meaning the user is not authenticated, redirect them to the login page. It's an elegant way to protect our application's roots, ensuring that only authenticated users can access certain parts of the app. The Navigate component from React Router plays a crucial role here. It programmatically navigates the user to a different route, in this case, login. This redirection is smooth and instantaneous, enhancing user experience by guiding users to where they need to be. Next, the Guest Layout component is designed to handle pages that are primarily intended for unauthenticated users, such as the login and registration pages. Its main task is to check whether a user is already authenticated and, if so, to redirect them away from guest-only pages. To perform its critical check, Guest Layout makes use of the useStateContext hook. This hook provides access to our global state, including the authentication token, allowing Guest Layout to make decisions based on the user's authentication status. So here we say if there's an authentication token, redirect the user to the homepage. This ensures that authenticated users are not navigating or stuck in the guest areas of the application. Now let's run our application to test everything. And we got some errors. Here there is two problems. First, we wrote the default layout function wrong, and the second is we have a problem with our import. The contexts folder starts with a small letter, not a big one, and we also forgot to add the imports to the guest layout, so we got an error there. Now after we have fixed everything, we can see that our application is working just like we wanted it to, and that's great. Now we can't access the users because we don't have an access token. Let's go to our context provider and try to add an access token. And then let's go to our main app and make the router inside our context provider, and now we can go to our application and try again. And we will go to the default layout. And if we try to go to the login page, we will be redirected to the default layout because there is an access token, and that's what we want. And then if we go back and remove our access token, we will go to the login page and we cannot access the default layout or the users page anymore. Now let's go the index CSS and paste the code of our styles. I will not write them, I will just paste them because they are too long and easy to write. There is a link in the description for the whole project and you can find the CSS file in there and copy it. Next, after we have made our CSS file, we will go to our default layout and start making our UI. We will make a div with the class name content, and inside of it we will make a new header. Now let's go to and see it, but first we need to add an access token so we can access the default layout. And we will, and after that we will get our header with the user info and header words. Now let's add to the users a name and call it John, for example, and try to access it in the default layout. To do so, we will just use the user and then dot and then name, and now we will get the name that we put, which is John. Let's try and see it. And we got John just like we wanted, and that's great. We now know how to pass data in our views. And let's add a link for the logout button to put next to the name of the user, and later we will write the logic for it. Next, let's make the login view. We will use the styling from the index CSS using class name, and we will make a new form to submit our data. we will need an email and password, and let's make the on submit and leave it empty for now. And let's in the end of the form add a button if the user doesn't have an account and with the link to take it to the register form. Now let's remove our access token and go and try the login form and see how it looks. And it looks great. Let's just remove the word guest from the guest layout. And if we press the link in the end of the form, it will take us to the register page, and that's great. Now let's make the design a little bit better and add a header for the form that says log into your account. Next, let's copy the login UI and paste it in the register form and edit a few things. Let's change the title of the form, and add a name field, and let's change the link down below to take us to the login form. And let's also copy the on submit and the imports that we need. Now let's go and try them, and the two forms are working fine and with the design that we want, and that's great. Now we need to make the logic for the authentication. We will need to use Axios for that. We will install Axios using npm install Axios command. But what is Axios that we are installing? In the realm of web development, making HTTP requests, whether it's fetching data from a server or sending data to an API, is a fundamental task. This is where Axios steps in. Axios is a promise-based HTTP client that enables us to make HTTP requests. You might wonder, why not just use the built-in Fetch API in JavaScript? While Fetch is powerful in its own right, Axios offers several advantages that make it a preferred choice for many developers. But what are those advantages? Axios provides a simple and intuitive API for making HTTP requests, with methods like Axios GET, Axios POST, Axios PUT, and Axios DELETE, making it easy to understand and use. Axios is built on promises, allowing for cleaner asynchronous code with straightforward error handling using then and catch. Axios automatically parses JSON responses, saving us the extra step of manually parsing the response data. Axios supports interceptors, allowing us to intercept requests or responses before they are handled, enabling tasks such as adding headers or transforming data. So now, after we have understood what Axios is, let's make a file called Axios Client and use it inside of it. Now what will we write in this file? First, in its simplest form, Axios Client is configured with a base URL that serves as the starting point for all API requests. Here's how it's done. By setting the base URL to our API's endpoint, we establish a centralized location for sending and receiving data, streamlining our API requests. One of the most powerful features of Axios Client is its ability to intercept requests and modify them before they're sent. This comes in handy, especially for handling authentication tokens. Here, we're intercepting each request before it's sent, retrieving the authentication token stored in local storage, and adding it to the request headers. This ensures that authenticated requests are properly authenticated, keeping our application secure. With Axios Client by our side, making API requests in React becomes a breeze. Its simplicity, flexibility, and powerful features streamline our development process, allowing us to focus on building robust and dynamic applications. In the realm of HTTP requests, errors are an inevitable part of the process. Axios Client comes equipped with response interceptors, hooks that allow us to intercept and handle responses from API requests before they reach the application. When a response is successful, Axios Client's response interceptor swings into action. It captures the response and passes it through to the application, ensuring seamless data retrieval. The success handler simply returns the response as is, allowing it to flow through to the application without any modifications. But what happens when things don't go as planned? That's where Axios Client's response interceptor shines. It intercepts error responses and provides us with an opportunity to handle them gracefully, ensuring a seamless user experience even in the face of adversity. Axios Client checks if the response status code is 401, indicating an unauthorized error. In such cases, it removes the user's access token from local storage, effectively logging them out and safeguarding their security. Finally, Axios Client ensures that errors are propagated back to the application, allowing developers to handle them appropriately. This enables us to display error messages, initiate retries, or take any other necessary actions based on the nature of the error. Now let's go to our register and add some variables. These variables are created using the useRef hook, which is a built-in React hook used to create a mutable reference to an element or a value that persists across re-renders of the component. Name ref, email ref, and password ref are being used to reference the input elements in your registration form. This allows you to access and manipulate the values entered by the user without directly querying the DOM, which is one of the main advantages of using useRef in React. So why do we use that? By creating references to input elements using useRef, you make it easier to access and interact with them programmatically. This is especially useful when you need to focus an input field, retrieve its current value, or programmatically trigger a form submission. In the context of a registration form, name ref, email ref, and password ref likely refer to the input fields where users enter their name, email, and password, respectively. These references allow you to access the current values of these input fields when the form is submitted, enabling you to send this data to the server for registration. Next in the onSubmit, let's make a new const and call it payload and put the name, email, and password values inside of it, and then let's console log the payload. Let's go to our register form and try to add a name, email, and password, and then let's go to our console. And we will find the data that we have, and that's great. And now let's add our Axios client and the set user and set token, and I will explain everything in the submit function. In our submit function, we first prevent the default form submission behavior using prevent default. This ensures that the page doesn't reload when the form is submitted, providing a smoother user experience. Next, we construct a payload object containing the user's name, email, and password. We retrieve these values from the input fields using the name ref, email ref, and password ref references created earlier. Now comes the exciting part. We use Axios client to make a post request to our server's register endpoint, sending along the payload we just constructed. Upon receiving a response from the server, we handle it accordingly. If the registration is successful, the server responds with data containing the user object and authentication token. We extract this data and update our application state using set user and set token, ensuring that the user is logged in and their details are up to date. But what if something goes wrong? Fear not. We've got error handling in place. If the server responds with a 422 status code, indicating validation errors, we log the errors to the console for debugging purposes. And there you have it, the submit function in our registration component, a crucial piece in the puzzle of user registration in React. By leveraging the power of state context and Axios client, we've created a seamless registration experience for our users. And the register form is working fine and everything is just like we want, and we are inside. Now let's open a new private window to test it again, because we haven't added the logout yet, and the register is working fine. Now let's make our login logic. It will be the same as the register, so let's just copy it and paste it in the login and edit the endpoint and remove the name, and then let's go and try it. We are logged in and everything is working fine. Now let's open our console and type local storage clear, and now our access token is removed. Let's try and log in without the password to test our validation. And we will get an error message because of that, so our validation is working fine. Now let's try and add a password. And we are logged in, and that's great.